Okay, so we're going to start by reviewing some of the rules that we learned last class. So when you multiply the bases, you add the exponents. Okay? When we divide the bases, we subtract the exponents. So I'm going to say that you get x equals m minus n, or if the bottom's bigger, you'll get 1 over x times n minus m. It depends which one's bigger. And if it's on top, then it stays on top, and we don't show the over 1 part. All right, so if I write it out in words, right, when we multiply, the same bases, they have to be the same. You can't have like an x here and a y there. When multiplying the same bases, you add the exponents. This would be when dividing. The same bases. Subtract. You subtract the exponents. And I'm going to say that they end up where the bigger exponent is. Meaning either on top or on bottom. All right, then I have x to the m to the n is going to be x to the m times n. So when raising a power to a power to another power, you multiply the exponents. This will be x to the n over y to the n, and we'll say when raising a fraction, sorry, got distracted there for a second. When raising a fraction to an exponent, you raise the numerator and denominator to that exponent. All right, so let's do some examples with those rules. So you can think of, you don't have to write this out, but how you think of it, you should think of it like this. Whoops, it's a times. In expanded form. So I've got a bunch of things multiplied together here, more than 10. I can multiply in any order I want. So I kind of rearrange them. I bring the numbers to the front, then I group all the x's together. I'm just going to say it and so on. So the idea here is that you can multiply just the numbers first because you're doing multiplication here. So I do 4 times 2, I get the 8. Now to do x to the third times x to the fifth, we follow the rule of adding the exponents. All right, let's look at B. This one, again, you don't have to write it out unless you need to. You should think of this as x squared times y to the fourth times x squared times y to the fourth times x squared times y to the fourth. Because the third means that I'm multiplying that 3 times. So how many times does x squared show up? X squared to the third. And how many times does y to the fourth show up? It shows up 3 times. So whenever you have an exponent outside to these other exponents, if it's multiplication in here, you can kind of raise each part to that power of 3. Now I can use the property or the rule that I multiply the exponents when raising a power to a power. So the x squared raised to the third becomes x to the sixth. The y to the fourth raised to the third becomes y to the 12th. There's a c over here. Okay, here when I'm dividing, again, I start with just the numbers. I divide those. 6 divided by 2 is 3. And then x to the 7th divided by x to the 4th is going to be x to the 3rd. because I subtract my exponents. You could think of that as if I have 7 x's on the top and 4 x's on the bottom. X divided by x is 1. X divided by x is 1. X divided by x is 1. These all make 1, and 1 times 1 times 1 times 1 times 1 just leaves you with this. 1 times x to the third, which is x to the third. All right, so for D, I've got to raise each part to the power of 3. Even the number. Remember, this has its own power, 2 to the first. So then 2 to the third is 2 times 2 times 2, which is 8. Then this is, by the property of power to a power, becomes c to the 15th. And then power to a power here becomes d to the 12th. All right, here I'm dividing. So the 2 divides into the 8, and this time the 4 ends up on the bottom. If I do my x's, I subtract because I'm dividing the bases of x, so it's going to be an x to the 7th up top. And then when I do the y's, it's going to be a y squared up top. So I can leave it like this, or if it's only a number on the bottom, I could also write it as 1/4 x to the 7th times y squared. You can do one. Dividing by 4 is the same thing as multiplying by 1/4. All right, this one, there's a couple routes you can go. You could simplify inside the parentheses first, or you can do the squared on the outside first. I'm going to simplify inside first. So that 2 divides into 4. So I get a 2 inside of here. A to the third divided by a becomes an a squared up top. My fraction bar is a little too long. And then there's no b's, so that b to the 5th stays on the bottom. And now it's that squared. So now I can apply the power to all of these parts. Remember, this has its own exponent. So it's going to be 2 to the 1st squared times a squared squared all over b to the 5th squared. So now simplifying each part, 2 squared is 4. A squared squared is a to the 4th because I multiply. B to the 5th squared is b to the 10th because I multiply. So that's going to be 4a to the 4th times b to the 10th. All right. Now we're going to look at another rule, some other rules that we can learn today. Those are with positive exponents. Now we're going to look at not positive exponents. So we're going to do this table backwards. So 3 to the 4th, the meaning of that is 3 times 3 times 3, and that equals 81. All right, so now let's do 3 to the 3rd. That means 3 times 3 times 3, which is 9 times 2, which is 27. Now we're going to do 3 squared, which means 3 times 3, which is 9. 3 to the 1st, which means 3, which is just 3. And now let's look for a pattern. As we move up this table, what are we doing each time? We're multiplying by 3 to get to the next one, right? So now we don't know what 3 to the 0 means and what the heck these we're going to learn rules for these negative exponents in 0. We already know what it means for the positive exponents. So we're going to do this we're going to continue this pattern on the right side of the table, and that'll tell us what this means. We're going to kind of work backwards now. So if I'm multiplying by 3 to go up the table, I'm dividing by 3 to move down the table. So if I divide 3 by 3, I get 1. If I divide 1 by 3, I get 1 over 3. We'll stop there for a second. All right? So 3 to the 0 really just sort of means 3 that I had first divided by 3, right? And now I have 1. Because 3 divided by 3 is 1. So then 3 to the negative 1 would mean like 1 divided by 3. Or we can think of it as 1 over 3 to the 1st. And that's how we get 1/3. So if we divide by 3 again, it's actually going to be 1/9, because what that means is taking 1/3 and dividing by 3 again, which really is equal to 1/3 times the reciprocal. Instead of dividing by 3, we can multiply by the reciprocal, which is really 1 over 3 squared, which is 1 over 9. All right, so what we want to look at is this meaning here. We can think of that as this. We can think of this as that. That's the key. So seeing that pattern, this means that we can write this as 1 over 3 to the positive 3. So when you have a negative exponent, it just means take the reciprocal and make it positive. So if the base 3 is on top of the fraction, you could think of this as 3 to the negative 3 over 1. I can move the base 3 to the bottom, like here, and I make the exponent positive. That's what you do with negative exponents. If they're in the top of the fraction, you can move the base to the bottom and make it a positive. You can change the sign of the exponent and make it positive. So what's 1 over 3 times 3 times 3, which is 1 over 27. All right, so from this table, we can learn a little bit about what negative exponents mean. So let's see what it means here. So first we're going to look at the 0 exponent. If it's not positive, then it's either 0 or negative. So raising any base to the 0 power means dividing by the base itself. That's what happens in this table. Whenever we do 0 power, we're dividing the base by itself. So we're always going to get 1. All right. Now, what does a negative exponent mean? A negative exponent tells you how many times to divide by the base. So exponent rules part 2. So we're going to write some more rules, make some generalizations. X to the 0 or any base to the 0 is always equal to 1 as long as X is also not 0 itself. So anything raised to the 0 power is 1. Okay, x to the negative n, that means 1 over x. I can think of it like that. I can make the power positive if I take the reciprocal of the base. So notice that became positive if I flip the base over. All right, and that if I apply 1 to the n over x to the n by my old properties, I get 1 over x to the n. Because 1 to the n doesn't matter how many times you multiply 1 by itself, you just get 1. All right, so this is the connection we want. X to the negative n equals that. So what we can say, like in words, we can say put the base in the denominator and make the exponent positive. Okay, so then what happens when we have a fraction here? Well, we can start with that same step as above. I can make the power positive, but then I have to flip the fraction or take the reciprocal. So notice that I switch the x and the y. And that's the same thing as y to the n over x to the n. So what we say here in words maybe is flip the fraction. Oops. Then make the exponent positive. All right, so we're going to do some examples here together. So 2 to the negative 3, that means put the base in the denominator and make the exponent positive. So now that means 1 over 2 times 2 times 2, which is 1/8. Okay. Example 2. If I have a negative exponent of a fraction, we can make our exponent positive, but we flip the fraction, and then that means 5 squared over 3 squared. So that means we have 25 over 9, right? So we made the exponent positive and we flipped the fraction. And then getting to this next step here, that's one of the old properties, okay? This is equal to 1 because anything to the 0 power is 1. This here is equal to 2 because anything to the 0 power is 1. Notice that the 2 is not raised to the 0. 2 has its own exponent, 1. Here, all this stuff inside here doesn't matter what it is. It's raised to the 0, so it equals 1. Here, 2 has its own exponent, so the part that's 1 is just that. So then 2 times 1 is 2. So x to the 0 equals 1, and then 2 times 1 is 2. All right, so here's some examples that we'll keep doing together. I'm going to do a couple with you, then I'm going to have you kind of finish them up on your own. Let's start by going backwards again. So let's start down here at the hard ones. All right, first I deal with the numbers. 8 divided by 2, I get 4, and it's on the top. Now, I've got y to the 6th, z to the 3rd, y. So I have a negative exponent. I'm looking for those. I want to make any negative exponents positive. So what I'll do is I'll bring that to the top. That's how we can make an exponent positive. If the base is on the bottom, we can move it to the top and make it positive. If the base were on top, I can move it to the bottom. So you switch it. Any negative exponents, you put them you move them either up or upstairs or downstairs and make their exponent positive. So that y to the 3rd travels up to the numerator. We still have a y to the 6 up there already and a z to the 3rd up there already, plus a z to the 5 on the bottom. I should say also, not plus. All right, so now up top, I can multiply in the numerator. I can multiply y to the 3rd times y to the 6th. When I multiply y's, I add the exponents. I get y to the 9th. Now I've got z to the 5th and z to the 3rd. So where are there more z's? There's more z's on the bottom. And I do 5 minus 3, so I get 2. So it's z squared on the bottom, right? Because you can think of that as z times z times z all over z times z times z times z times z. That equals 1, that equals 1, that equals 1. So I have 1 over z squared. I only have the z squareds on the bottom, right? That's that rule of wherever there's more z's, that's where they end up. All right, let's do this guy. So I see there's a couple ways, again, that you can go about this. I see that I can multiply the 2 times the 4 and get the 8. Now I can multiply the r to the 6th times the r to the 8th. So I'll get r to the negative 2. How did I come up with that? When you multiply r's, you add the exponents. And 6 plus negative 8 is negative 2. I don't want to leave negative exponents in my answer, so you can think of this as like over 1. Whenever I have a negative exponent, I can move the base. Since the base is in the top, I can move it to the bottom, and then my exponent turns positive. Okay, we look at this guy. I have a fraction to a negative exponent. So what I can do is flip the fraction and make the exponent positive. So I want to do that first. Then I can raise the 3, everything to the 3 in here. So 3 to the 3rd is what? 27 times y to the 3rd. 8 to the 3rd is 64 times 8. I don't know what that is. I'm going to bust out the calculator. $512 x cubed. All right, let's try this one. There's a couple ways you can go about this. I see a negative exponent on the outside, so I think of the fraction as that. So I'm going to flip the fraction and make my exponent positive. Now I can do 1 squared over 9 squared w squared. So 1 squared is 1, 9 squared is 81, w squared. All right. 6x to the 0. Well, I know x to the 0 is 1, so it's 6 times 1. Because anything to the 0 power is 1. Remember, 6 isn't to the 0. 6 has its own exponent, 1. So it's just this part that's to the 0. So then 6 times 1 is 6. This part, this whole thing is to the 0, so that's like a 1 times 1. This part is going to be 2a to the 3rd squared. So since I have an outer squared, I'm going to square all the parts on the inside. Remember, that's like a 2 to the 1, 2 to the 1st. And then times 1, I don't need to show times 1, right? Doesn't do anything. So 2 squared is 4. A, and then it's 3 times 2 because I have a power raised to a power, so I multiply my exponents. Looks like we'll just do all these together. All right, here I'm dividing b's, so I subtract the powers. Where are there more b's? There's more b's on the bottom, so that's where they end up. So I got to put a 1 up top to show that. So 7 minus 5 is 2. There's 2 left on the bottom. All right. Keep in mind, if I had b to the 7 over b to the 5th, it would be b squared. I don't need to show over 1 when the 1's on the bottom of the fraction. I just need to show it when it's on the top. Actually, that wasn't a question, so I don't want to leave that there. All right. Ooh, here's an interesting one. If I multiply my x's, I add the powers. So 3 plus negative 3 is x to the 0, and then anything to the 0 is 1. So this is 1. I've got a fraction to a negative exponent. So I flip the fraction and make the exponent positive. Now I can apply that exponent to all parts of the fraction. 3 squared is 9 over x squared. X to the negative 5th. So if I have a negative exponent, I move the base to the bottom if it's on top. And you can think of that on top. When they don't show you a fraction, you think of it as being the top of a fraction, where 1 is in the denominator. So I move the x to the bottom, and I can make the exponent positive. So now it's 1 over x to the 5th. Here I've got a fraction to a negative power. So I flip the fraction and make the power positive. Then I apply the power to all parts of the fraction. So 7 to the 3rd is what? 49 times 7. I don't know that one either. 343. 2 to the 3rd is 8. And lastly, I've got 10 to the negative 4th. So again, think of it as over 1. So it's going to be 1 over 10 to the positive 4th. It's going to be 1 over, it's got 4 zeros. That's how I raise 10 to a power. All right, so now you have some practice that you can do when you're done with your notes on the video.